Hello sailors, I'm Captain Tom Tersey from the Maryland School of Sailing and Seamanship. I'd like to tell you about one of the methods used for collision avoidance at sea using a paper plotting chart plus either your radar or your AIS to get distance and bearing data to an approaching vessel. This method is mostly applicable to large open ocean areas or coastal cruising as opposed to constricted inland waters. With it, you can determine not only the closest point of approach, CPA, between vessels, but also which side of you the other vessel will pass and the course change that you will need to make to increase the CPA to a greater distance if desired. The maneuvering board, also known as a MO board in Navy parlance, is a paper chart about 13 inches square used to represent what you see on the radar screen. Your vessel is considered to be located at the center of the maneuvering board, which has a 0 to 360 degree scale around the periphery. It also has 10 concentric rings numbered from 1 through 10. These can be used to indicate either distance in nautical miles from the center of the maneuvering board or speed in knots, and we will be using both of these scales in subsequent examples. Here's how it's done. For example, you are on a nominal course heading of 40 degrees magnetic at 4 knots. Your radar display is set to north up. At 0200, your radar shows another vessel on a bearing of 70 degrees magnetic at 9.5 nautical miles. Draw a dot on the maneuvering board at this bearing and distance and mark it with the time, 0200. 15 minutes later, at 0215, the other vessel bears 69 degrees magnetic at 8.0 nautical miles. Again, draw a dot on the maneuvering board at this bearing and distance and mark it with the time, 0215. At 0230, the other vessel now bears 67 degrees magnetic at 6.5 nautical miles. Plot this point on your maneuvering board and mark it with the time, 0230. Now draw a straight line between these three dots and extend it past your vessel at the center of the maneuvering board. This line represents the position of the other vessel relative to you based on the course and speed of both vessels, and we will refer to it as the relative course and speed line, RCSL, as shown here, where the direction of relative motion, DRM, is the direction from the 0200 point on the maneuvering board toward the 0230 point. Here the DRM equals 256 degrees magnetic. The speed of relative motion, SRM, is calculated based on the distance D1 between the 0200 and 0230 points divided by the elapsed time as shown here. SRM equals 3.0 nautical miles divided by 1/2 hour equals 6.0 knots. Remember, SRM is the closing speed between you and the other vessel based on the movement of both vessels. Based on the RCSL, and assuming no change in the course or speed of either vessel, read that the closest point of approach is projected to be 1 nautical mile at the location marked CPA here on the maneuvering board. Also note that the other vessel will pass ahead of you and cross your bow from right to left. You continue on a course of 40 degrees magnetic at 4 knots. If you are concerned that a potential collision or near miss is possible, call the other vessel on VHF 13 or 16 to discuss and agree on passing plans. You agree that the other vessel will maintain course and speed, and that you will change course to starboard to increase CPA to 2 nautical miles. You plan to execute this course change at time 0245. How do you calculate the course change necessary to increase CPA to 2 nautical miles? Here's a summary. First, calculate the other vessel's actual course and speed. Next, decide what time you will execute the course change and mark this point on the RCSL line with an X. Then draw a new RCSL line extending from X to a point of tangency with the 2 nautical mile circle. And finally, calculate the necessary course change based on the new RCSL. Here are the details. Draw your vessel's course and speed vector at 40 degrees magnetic and 4 knots. This is drawn as shown from the center of the maneuvering board in the direction of 40 degrees magnetic and out to the 4-knot circle. Draw a copy of the relative course and speed line RCSL previously determined to pass through the arrow tip of your vessel's course and speed vector. You and the other vessel are closing at 6.0 knots based on the speed of relative motion, SRM, previously determined. So you need to measure the length of this copy of the RCSL line to represent 6 knots. Do this by first setting your dividers to a 6-knot speed measured from the center of the maneuvering board in the direction of the 6-knot circle. Now move the divider point to the arrowhead at the end of your vessel's course and speed vector and mark off the 6.0 knot length on the copied RCSL line using the divider pencil as shown. This copied RCSL line forms the second side of a speed vector triangle where the direction of the arrow represents the closing direction, DRM, between the 2 vessels, and the length of the arrow represents the closing speed, SRM, between the 2 vessels. The third side of the triangle will represent the course and speed of the other vessel and is drawn from the center of the maneuvering board out to the arrowhead on the copied RCSL line. This shows that the other vessel is on a course of 297 degrees magnetic at a speed of 3.6 knots. Next, in order to calculate the course change that you need to make, let's focus just on the original RCSL line and the other vessel's course and speed vector for the following. Calculate the distance, D2, between times 0230 and 0245 on the original RCSL line. This is a time difference of 15 minutes, or 1/4 of an hour, and the distance D2 is calculated as follows. D2 equals 6.0 knots times 0.25 hours equals 1.5 nautical miles. Measure this distance from the 0230 position and mark it as point X and mark the time 0245. Draw a new RCSL line between point X and tangent to the 2 nautical mile circle. Now calculate the course change that you need to make to increase the CPA to 2 nautical miles as follows. Draw a copy of this new RCSL line through the arrow point of the other vessel's course and speed vector. Draw your vessel's new course and speed vector on a heading that allows its 4-knot length to start from the center of the maneuvering board and touch the copy of this new RCSL line. This point will occur where the copy of the new RCSL line intersects the 4-knot circle of the maneuvering board. As shown here, this requires that you change course from 40 degrees magnetic to 64 degrees magnetic and maintain your 4-knot boat speed. This course change by you will increase the speed of relative motion between you and the other vessel from 6.0 knots to 6.8 knots, which you can determine by measuring the length of the new relative course and speed line. This assumes that the other vessel maintains its course and speed unchanged. And in closing, in this age of super electronics that can do everything at the touch of a button, this procedure may seem unnecessarily burdensome to some sailors, as automatic plotting software can do it for you. Automatic plotting software available for commercial ships, ARPA, can do this plotting, but recreational vessel software, MARPA, can do it only partially. Manual plotting gives you a geographical representation of what the radar or AIS screens are showing, namely whether the other vessel will cross ahead or astern of your vessel and from what direction it will cross. As in all navigational practice, basic paper and pencil plotting gives you a broader and more comprehensive understanding of what is happening as compared to simple button pushing. So sailors, I hope you find these techniques helpful in your future encounters with other vessels at sea. And thank you for participating.